Human rhinoviruses from the coronavirus family cause approximately 50% of cases of the common cold. There are over 150 serotypes of rhinovirus across 3 species, HRV-A, HRV-B, and HRV-C. Their genome is a single linear positive RNA strand, meaning it can function as mRNA and be directly translated by host cell ribosomes for the synthesis of structural and non-structural proteins required to produce new rhinovirus virions. Non-structural proteins include RNA-dependent RNA polymerase, RNA replicase, which facilitates genomic replication, and viral proteases, which cleave a translated polypeptide chain, a polyprotein, into individual mature proteins. The structural proteins compose the viral capsid, a protein-based shell that surrounds and protects the RNA genome. The capsid has an icosahedral symmetry and is non-enveloped, meaning there is no lipid-based additional layer exterior to the capsid that some other viruses, such as influenza, gain from the cell membrane of a host cell. The capsid of each virion consists of 60 subunits termed capsomeres, each containing copies of the 4 main structural proteins, VP1, VP2, and VP3, which are on the surface of the capsid, and VP4, which is on the internal side. VP1 facilitates attachment and entry into human cells. Most HRV-A and all HRV-B cell types bind VP1 to intercellular adhesion molecule 1, ICAM1, a glycoprotein and adhesion receptor present on ciliated epithelial cells in the respiratory tract. Some HRV-A cell types alternatively bind VP1 to a low-density lipoprotein receptor, whereas HRV-C cell types can bind to a cadherin-related family member 3 receptor. Upon binding, a rhinovirus will enter a host cell via receptor-mediated endocytosis. Receptor binding and subsequent acidification within an endosome causes the uncoating of the capsid, and released VP4 proteins form a pore in the endosome's membrane, allowing the RNA genome to pass through to the cytosol. The rhinovirus RNA genome will be replicated by a complex containing RNA-dependent RNA polymerase and other non-structural proteins. This includes 2B, 2C and 3A, which induce vesicle formation by the host cell's Golgi body or endoplasmic reticulum to function as organelle-like sites, termed replication organelles, for the viral genome and replication complex during replication. A VPG protein acts as a primer to produce a negative RNA strand via RNA polymerase using the positive RNA strand as a template. The resultant temporary double-stranded RNA molecule separates, and the negative RNA strand is used as a template to produce a new positive RNA strand. Structural proteins are assembled and form a capsid around each new positive RNA strand. The new virions will then mature and accumulate in the cytosol until the host cell lyses, releasing the virions to infect other cells or exit the host body within respiratory droplets for transmission to a new host.